Hi friends, welcome to my channel. Now we can discuss easy trick used to determine bond order. Okay, so bond order is the number of bonds exist between two atoms in the given molecule. So this bond order, how can we determine in the shortcut methods? Let me see now. First, draw one V-shaped line. Then write number of electrons in the increasing order 8, 9, 10, 11, 12, 13, 14. And then rises to 15, 16, 17, 18, 19 and 20. That indicates number of electrons. And then next side, bond order slightly increases from 0 to 0.5, 1, 1.5, 2, 2.5, 3. For the 14 electrons, the bond order is 3. And then it's going to decrease 3 to 2.5, and then 2, and then 1.5, 1, 0.5, 0, bond order for the electrons 20. And then in the smaller line, as usual same manner, the electrons from 2 to 6, bond order varies 1, 0.5, 0, and then increases 0.5, 1. So bond order, so now we can determine for the given diatomic molecules like O2. O2 means it is obtained by combination of two oxygen atoms. So atomic number equals to number of electrons. That's why 8 electrons in each oxygen atom. Therefore total electrons is 16. For the 16 we can determine bond order. 16 electrons is here, its bond order is 2. And then for example for the other one, O2 plus. So O2 plus means O2 8 into 2 16 electrons, plus charge means 1 electron is removed, therefore minus 1 electron, it equals to 15 electrons. For the 15 electrons, bond order is 2.5. And in the same manner for O2 minus, we can write so 16 electron for the O2 molecule, minus means 1 extra electron, that is overall electrons is 17 electron. For the 17, bond order is 1.5. In the same way for the nitrogen molecule, it is obtained from nitrogen, combination of another nitrogen, that is each nitrogen contains 7 electrons, therefore total electrons is 40. For the 14, bond order is 3. In the same manner, N2 plus, so 14 electrons minus, that means 1 electron removed, so 1 electron removed, that's why 13 electron, therefore for the 13 electron, bond order is 2.5. So like this we can determine bond order in the shortcut method for the any given diatomic molecules. For the Li2 molecule, so Li plus Li, that thing, so 3 electrons plus 3 electrons, total 6 electrons. For 6 electrons we can determine here bond order is 1. Bond order is equal to 1. Bond order is 1. In the same manner, Li 2 plus means 1 electron is removed, so out of 6 minus 1, that is 5 electron in Li2 plus, so then 5 electrons means bond order is 0.5. For the polyatomic molecules, we can determine bond order using the formula number of resonating bonds divided by number of resonating structures. number of resonating bonds divided by number of resonating structures. For example, you can consider PO4 3 minus. So you can write the PO4 3 minus structure: phosphorus, double bond O minus, O minus, and O minus. So bond order equals, first count number of resonating bonds. Number of resonating bonds means total bonds: 1, 2, 3, 4, 5. Number of resonating bonds is 5. Total bonds is the number of resonating bonds. 5 divided by number of resonance structures obtained by individual bonds, single bonds. So number of 1, 2, 3, 4 only. Double bonds also considered as 1, 1, 2, 3, 4. 5 divided by 4, then you can get bond order 1.25. Okay, 1.25. Therefore, PO4 3 minus bond order is 1.25. Number of resonating bonds, that is the total number of bonds, is the number of resonating bonds, and number of resonance structures you can consider only single bond: 1, 2, 3, 4. Okay, so 5 by 4, that is the bond order 1.25. In the second example, SO4 2 minus, you can write like this: double bond O, O minus, and O minus. Then bond order equals total number of bonds and number of resonating bonds. Sorry. So that is a 2, 4, 5, 6. 6 divided by number of resonance structures: 1, 2, 3, 4. 4 now. So therefore bond order is 1.5. Okay, like this you can determine bond order of polyatomic molecules. Next, we know bond order inversely proportional to bond length. That means higher the bond order, shorter the bond length. For example, if you are going to arrange the molecules in the decreasing order for N2 plus O2 and O2 minus, we can determine bond order first. So 7 into 2, 14 electrons. 14 electrons means bond order 3. And then for N2 plus, so 14 minus 1, 13 for bond order 2.5. And then for O2, 16, 8 into 2, 16. For the 16, bond order is 2. And then O2 minus 16 plus 1, 17. The bond order is 1.5. Then order of decreasing order is N2 greater than N2 plus greater than O2 greater than O2 minus. Okay, so as usual, same, you can determine bond order and write the bond length increasing order and the decreasing order. It's bond order in decreasing order. Then bond length decreasing order. You can mention like this: reverse O2 minus greater than O2 greater than N2 plus greater than N2. So higher the bond order, shorter the bond length. Okay, so like this you can determine the bond order and bond length and the relation is bond order inversely proportional to bond length. In the same manner, bond order directly proportional to bond energy. Therefore, higher the bond order, higher the bond energy. Like, share and comment to my channel.